So just a little bit about me. I own a company called the Good Seed Company. Our tagline is heirloom seeds for common use. And I agreed to take this company over. It was a friend of mine actually in Washington State. And he was in his late 70s. He'd been growing and living off the grid and growing all his own food on 600 acres up in the Okanagan Highlands, and had to do a lot of work to identify varieties that did well in their climate. And their climate's very similar to ours. So he saved all the seeds, and then he started to sell them. And then when he got into the mid-70s, he decided, okay, that's enough of that. And it was right about the time the internet was taking off, and it was just, we want to figure that out. So, but I took it on because of, just with my background and interest, I was finding myself learning about the state of our seed. And our tagline is heirloom seeds for common use, because we have survived to this day and age as human beings because we learned to save seeds, and we learned to share, and we had free capacity to share seeds. And that's actually becoming more and more difficult with the industrial model of seed saving and seed production. So common use means available to all. And that's what we're all about, is we only sell varieties that are in the public domain and that are savable. And we spend a lot of our time teaching people to save seeds. Our goal is to be, obsolete, hopefully, because people are saving their own seeds and our community has built up its seed supply. So that's really what the seed company is all about. And what I learned, and I actually thought this was, I didn't know anything, which is probably a good thing. But what I learned as I started this process is that somehow, by the time we've gotten to this day and age, a lot of us have come to this perception that, one, growing is hard, and two, seed saving is this complicated thing, and other people know how to do it, and I can't. Like I need a PhD or something. And I'd just like to remind everybody that the first people who saved seeds didn't have a PhD, And so we all can save seeds, and we've been doing it for so long that it's actually in our DNA. Like if you start this process, your intuition will tell you what to do next. It's super easy, it's not complicated. And I'm just gonna walk us through some 3 basic questions that are good to ask yourself when you're seed saving, when you're planning your garden for seed saving, so that you can be more successful. And that's it. So, what's at stake? So, why is this so important? Just as I started to say earlier, about 100 or so years ago, we had 96% more varieties of agriculturally important crops in the United States than we have today. We've lost 96% of that biodiversity. It's just gone. And it's gone, well, before we get there, why is that important? So we as humans, created all the biodiversity that we have. And we've done that over 16,000 years of just identifying crops in the field that we liked and selecting for characteristics that we appreciated, and then saving the seeds from those varieties that we like and sharing them with others. So I like to point this out. This is what a wild carrot looks like. Pretty different from the carrots we eat today. That's wild corn. And of course, wild old wheat or original wheat. Very different from modern wheat. And we did all that. Our ancestors got us from wild corn and wild carrots to the orange and now purple carrots that we eat today. So we have that knowledge and capacity, and it's just come from selecting for characteristics that we think are important. And of that selecting, saving, and sharing seeds, all 3 of them are important. And sometimes I argue that the most important of those is the sharing, because it mixes up the DNA and it maintains the biodiversity. And if you think about it, pretty much every species on the planet requires a mixing up of the DNA to keep the vibrancy of the genetics strong. We have cultural mores as humans in every culture that prevent us from procreating with our siblings, because we know that just doesn't produce strong bonding. So, we as humans do that, and pretty much every species on the planet does it, and so do plants. And so it's really important to allow allow the DNA to mix. And you do that by sharing seeds with others. I'll take just a quick second. There's a gentleman named Will Bonsall who tells a story. He's a farmer in Vermont, and he tells a story of there's a hollow in the northern parts of Vermont where about 100 years ago, all the farmers grew one type of corn because it did really well in this hollow, which tended to get a lot of frost. And I think it was called white manure or something. And but corn, as we'll learn in a minute, hybridizes very quickly and cross-pollinates pretty easily. And corn pollen can travel long distances, over a mile. So if you're wanting to save a particular variety of corn, you want all your neighbors to grow that same type of corn. But corn also is subject to inbreeding and genetic, what's it called when I'm blanking on it, but when the genetics will go down pretty quickly if you don't share the seeds, if you don't mix up the DNA. The word will come back to me. Depression. Pretty quickly. But at any rate, what is it? Depression. Depression. There we go. Thank you. So anyways, in this hollow, what they would do is at Christmas time, so everybody grew white lightning, midnight lightning corn, and it was because it was a good sweet corn, but you could also feed it to your domesticated animals, and it also made a good flour corn. So anyways, at Christmas time or in the holidays, everybody would go visiting to all the other neighbors' farms, and you would bring a mason jar and a bag of corn from your own stock. And you'd go to before you went into your neighbor's house, you'd go to his barn, or her barn, and you take out a scoop of corn into your mason jar, and then you dump your corn into his stash. And now you had some of his midnight lightning corn to take back and plant, mix up with yours and plant, and he had some of yours. And if everybody did that, it kept the genetics and prevented genetic depression of the corn. So. Okay, so now the last thing about this is that in order to do that, you have to have a variety with stable genetics, and this is what we call open pollinated or heirloom seeds. Heirloom simply means that all the, yes?
What would an example of unstable genetics be?
So a new hybrid, and we'll talk about that in a minute. When you first cross-pollinate two plants and produce the progeny seed, the genetics are pretty mixed up in there from two different varieties, and you're less able to predict the outcome of the progeny seed, and we'll walk through that in a minute. So I think what I was going to say is that heirloom seeds are simply open pollinated seeds where we have selected for a particular characteristic that we like and shared that with ancestors, friends, or not ancestors, but next generations. So back to this question of how did we get here. How we got here is in the seed industry has started probably over the last 60 or 70 years, started to develop, or actually it's probably closer to 100, has developed more and more hybrids. And a hybrid seed is where you have two parent varieties that have a characteristic that you like, and you've inbred them so you can be guaranteed that the genetics will always produce that characteristic that you like. And then you crossbreed those two inbred parents, and you produce a new variety that's this special great hybrid. And the food that you eat from that hybrid seed is going to be great and delicious, but the seed that hybrid plant produces is going to have messed up genetics. And I often talk about this in the context of dog breeding because people seem to get that easier. So if you think of, these new poodle-related doodles, right, whatever they are, labradoodles. So somebody has taken, so when you make a new dog breed, I think we all understand, the dog breeder is selecting for the characteristics that make that labradoodle. And now all the labradoodles have really stable genetics. And the same thing with the poodle. But now when you cross the poodle and the Labrador, you get a lot of cute puppies, but they're going to be all kind of mixed up. Some are going to look more lab, some are going to look more poodle, some will look like what we want is a Labradoodle. To to create the new breed of a Labradoodle takes a lot of crossing of these next generations until you can sustainably produce everything that will always look like a Labradoodle. Does that make sense? You're going to be doing that for several generations. So that's the same thing. That first generation of these mixed up puppies is the same thing as what we would call a hybrid at the plant level. If you would imagine that instead of puppies you had seed and then you planted those, you can't guarantee what this next generation is going to look like. And oftentimes, because of the way that inbreeding happens, the seed is often sterile. So it's difficult to reliably save seed from a new hybrid. And so the tendency is to just not focus on that, and just, which is good for a seed company because that means you'll keep coming back to me to buy more seed. Not necessarily me, but someone who sells hybrid seed. And that's been quite attractive to the seed industry. So there's this big tendency to move towards more hybrids. We want the latest, fanciest kind of variety of tomato or corn or carrot. And we've come to just rely on the seed company to provide the seed, and we don't have to save it. So the seed companies are making more hybrids, so there's less open pollinated seed, and there's more plant patenting. So now the seed companies are also claiming that they own the genetics of these new varieties, and that limits our access to them. And they're controlling which varieties they're selling. So we are losing the varieties because we're losing access to the seed. There's also genetically modified seed, which is also impacting the variety of seeds available to us. And then there's the consolidation of seed companies. So it's worth breaking this up because I don't think we necessarily know this. Up until 2017, between 2013 and 2017, the industrial seed industry was dominated by six major companies. The big companies are, the chemical aspects of these companies are in red, the seed companies are in blue, and the green companies are genetically engineering companies. But they manage over 90-some-odd% of the industrial seed supply for the world. And then in 2017, and you'll notice that the major, and the size of the circles has to do with their market share. And of course, we're all familiar with Monsanto, that it rings a bell to everybody, whatever you may think of them. But you'll notice that the market share is held by chemical companies, and they own seed companies. And then in 2017, there were 3 major mergers in the tens of billions of dollars, and consolidated these. Monsanto merged with Bayer, which is the little one on the right you can't really see, for $66 billion. DuPont and Dow merged for $130 billion. And Syngenta, which is a chemical company, merged with a company that nobody had ever heard of called ChemChina, because they were out of China and nobody knew they existed. They're the largest chemical company in China. And this is what it looks like today. So now we just have 3 major players. Monsanto has disappeared. It's now fully owned by Bayer. So the name Monsanto is likely going to disappear. And then DuPont and Dow have come up with a new name, which I can't, Corteva, I think is what it is. Yeah, Corteva. And Syngenta have been subsumed by ChemChina. So it's just an FYI. And the decisions that are being made about which seeds are important are being made by a chemical company. It's just a different mindset than the way we as gardeners think about seed. I'm not going to go into it too much more. There's a community conversation happening this afternoon about the seed industry and the issues with it and the solutions that we can come up with, and I invite you all to attend. It starts at 1:15. But I do think it's important that we all know what's happening. So, back to us and why we want to save seed, and why biodiversity is important. All the species that are still on the planet today have the ability to be adaptive to change. So we've got algae and sharks and flowering plants and bees that have been around at least 30 million years. And they have all learned to be adaptive to change. That's a key to resiliency. So biodiversity is important for resiliency. And as humans, we're still trying to figure that out. And in order to survive, to figure that out as humans, we have to be able to eat. In order to be able to eat, we have to be able to have access to biodiverse and resilient seed. So I do also just like to point this out. People often ask about the seed vault in Norway. This is the work of Carrie Fowler, an American conservationist who gathered seeds from all over the world and had them buried, Norway build this, it's called the Doomsday Vault, and it's saving a supply of open pollinated seeds from every country in the world under about a mile of permafrost on an island called Svalbard in the North Pole. And that's fabulous, and that's wonderful, and that's amazing. It's one of the few things every country in the world has agreed to without any issue or frustration, because we all get that seeds are important. But it's under, a mile in Norway, and that's not going to do us in the Flathead Valley a whole lot of good, if in fact the world does have a catastrophic effect. So, which is why we want community seed saving programs. So, Free the Seeds is focusing on community food systems. They're very important to our viability as a species and as a community, and of course at the top of that starting point, which is producers and food, we need to start with seed. So saving our seed and providing a local seed supply of vibrant, biodiverse, genetically strong seed is key to a vibrant system. All right, so that's my plug about why we should save seed and why it's so important. And now we're going to get to our questions. We're going to focus on these 3 questions. I'll walk us through them one by one, but here they are. When you want to save seeds, the first question to ask yourself when you're going to grow the plant is, are the seeds I'm about to plant going to produce progeny seed that will grow true to type? Will it produce basically the same plant that I grew today? So that's called true to type. And 2, does the plant that grows from the seed self-pollinate? Does it pollinate itself, in which case we call it a selfer? Or is it promiscuous? Is it cross-pollinate? So are they selfers or crossers? And 3, knowing what kind of seed I have, a selfer or a crosser, what do I need to consider when I'm planting that seed? So those are the 3 questions. So will my seeds grow true to type? So this is the open pollinated versus the hybrid. We walked through that already. Hybrids, generally speaking, will not grow true to type, and GMO seeds will not grow true to type. I'll get to GMOs in a minute. So just basically you want to be able to start with an open pollinated seed. Now, the scary part is that I used to be able to stand up here and say open pollinated seeds are in common use. Now I have to be careful about that, because the seed companies are taking those hybrids and doing the work to convert them into open pollinated seed, but they're doing them under the constraints of a patent, so that even though they're open pollinated, and they may sell it to you, and you may have a license to plant that seed and eat the crop that you grow from that seed, you may not have a license to save the seed from that crop. That's what's happening here. So that's pretty freaking scary to me. So the Good Seed Company only sells open pollinated seeds that are in the public domain. All these things are hundreds of years old. And I don't look at newly open pollinated seed, because that's just not what we're all about. Because I want to be able to have confidence to say, you can save this seed, this is your seed. I also want us to understand that I believe this is our right as humans to have access to these seeds. And it's just incredibly devastating to me to see that we're limiting that capacity from a mindset that has no understanding of our history and our future. Okay. So the thing about hybrids, if you buy hybrid seed, again, there's nothing wrong with hybrid seed for eating. The package will either say hybrid on it, and I've circled it up there, or it will say F1. In Europe, because that's just a scientific term for the first generation, filial one is what it means. And in Europe, they tend to use F1 as the designation. In the US, we tend to say hybrid on our package, but it'll say one of the three. Now, I want to point this out. You'll notice that the middle packet says organic. And people kind of get confused between organic and hybrid and open pollinated. What do all these terms mean? So I want to take a minute to talk about that. Organic has to do with the way we grow our food or our plants. It means that we grow, we start with non-GMO seed, and then we grow it under conditions that are defined as organic. And I've got them up here on the corner, which means without pesticides, chemical pesticides, without fertilizers that have sewage slug synthetic ingredients, and without ionizing radiation. So those are the definitions for certified organic. So you can have a hybrid seed, and it would still, that is organically grown, and that's completely fine. But it's important to pay attention to the difference. Does that make sense? So the hybrid has to do with the seed. Organic has to do with how that plant was originally grown, how that seed was originally grown. Or the plant that produced that seed, rather. Moving on to GMOs.
So the
Yes.
absence of hybrid or F1 means it's open pollinated.
Yes.
They don't label it.
Unless it says GMO, and you won't. So for GMOs, just so you know, GMO seeds are currently not available at the backyard gardener's level. So you should not, at least for the time being, ever have to deal with a seed packet that says GMO, but you are required to label it if it's in fact GMO versus GM. That's what we say. Go ahead.
So just make sure that I'm understanding the term open pollinated
Sure.
correctly is basically if you're making a hybrid, it's closed pollinated because you only want a certain component of it.
So the phrase open pollinated meant that you could grow this variety in the presence of other members of the variety and still produce more progeny of the same. Whereas when I'm trying to make a hybrid, it's highly engineered in terms of the cross-pollination. I pick a very select inbred parent of one line that has, I don't know, the yellow banana pepper. And then I have another inbred parent of another line that's got a particular chipotle flavor. I'm making this up as I'm going. And I produce a hybrid that's yellow and makes a chipotle flavor. But if I just then now take that hybrid and let it pollinate among its progeny, I'm going to get a gamish moving on. I'm not going to get more yellow chipotle. So does that make sense?
Yeah. So
Okay.
open pollinated means both likely that the seeds that you're buying were created from plants that were just hanging out with other plants.
And their genetics are stable.
Right.
I haven't just been, two inbred parents haven't just been cross-pollinated. Okay, so just a minute about GMOs. So far, they have typically been commodity crops, which are the soy, canola, cotton, sugar beets, rice, and cereals that are up at the top. They're starting to get into the plant varieties, and I've highlighted those there. Historically, genetically modified organism plants were developed in order to create a mechanism for being able to treat a field with an herbicide without impacting the plant of interest. And not surprisingly, over time, the herbs that we were trying to kill developed a resistance to the herbicide, and so we've not been successful. That approach has not been successful. Let me just move on here. And the reason I am stopping myself is that we used to be able to rely on the requirement for labeling of genetically modified organisms. And this was mostly through the work of Monsanto, the way they did this is they had an organism that was from a different species that they had to inject in a laboratory process into the genetics of the plant. And so that was a genetically modified organism. But now, you can actually modify the DNA without inserting an organism, gene from a different organism. So that labeling actually is going to be going away, although it's going to be producing the same result. So you won't have access to that knowledge about GMOs that we used to rely on, which is where organics is going to become more and more important as a definition. So the second piece that I think it's important to know, because this goes back to the organic and the understanding about how plants are grown. The active ingredient in Roundup, which was the herbicide that was the reason for creating these GMOs in the first place, was a broad spectrum herbicide. Great, okay, fine. But now what they've discovered is that I'm not going to go through the mechanism because I realize I'm talking too much and I haven't gone to the seed saving. I apologize. What I want to say is that the mechanism by which glyphosate works, which glyphosate is the primary ingredient in Roundup, is it's a desiccant. And so they have discovered that it's actually a useful product to spray on any plant, whether it's a GMO plant or not, towards the end of its life when you're trying to mature the seed. And a crop where you're trying to mature the seed is wheat, right? We use mature wheat seed for our grains, for our breads, for our cereals, for our crackers, all other grains like that. And it turns out if you spray glyphosate on the crop while it's trying to mature, you can speed up and you can kind of dial in the timing of maturation. So it's a very efficient system from a farmer's perspective. And we have now absorbed a whole lot more glyphosate as consumers than we used to, because this application towards the end of a plant's life doesn't require, it's useful on all plants whether they're genetically modified or not. So there's no way to know whether, unless you buy an organically grown product, unless you buy product from organically grown food, there's no way to know whether it's been treated with glyphosate or not. So these are pre-harvest desiccation crops: corn, cereals, oilseeds, legumes, sunflowers, potatoes, and cotton. These are products where they have identified glyphosate in the products. These are things that our children are eating. These are things that we think are safe. Yeah. But, and I don't mean to point out Kellogg's, this is probably just where I cut this out. You know, no one's paying attention. No one's telling us this is just happening, period. Okay, so let's go back to what we can do. Let's go back to our seed saving. In order to understand about sulfurs or crossers, let's just take a quick look at the parts of a flower. So the green stalk in the middle is the style, and at the very top is a stigma, that thing that looks like a helipad landing surface. So that's where pollen, that's the female part of the plant. That's where pollen, which is made by the anthers, those two yellow things. If that pollen lands on the stigma, it's sticky, and then the pollen then will travel down that tube to these ovules, which are basically plant eggs, fertilize them, and that's where your seeds are made. So on some plants, you'll notice that both the anthers and the stigma are within the same flower, and that's called a perfect flower. And on some plants, I'll come back, the flowers, the male and female parts are on different flowers, on different parts of the plant. Or they can be on different plants. So here's, if you think about the corn plant, the tassel, that's where the pollen is made, is at the top. But all those silk ears, those are the stigmas. So when the pollen sticks to the top of the long little silk ear and travels all the way down, and when it pollinates this little ovule, that's how you get your corn kernels. Have you ever gotten a corn, opened a corn cob, and it's only half the kernels, they only start halfway down, so that means the top half didn't get pollinated. Okay, so and here's squash flowers. The male flower is here. The stigmas, the anthers are inside. And next time, if you don't know this, next time you grow your squash plant, you'll notice that some of them have these bulbs at the bottom, and that's where the ovule is. And so, squash plants are pollinated by insects, and they're pollinated by a lot of land insects, land bees that will sleep inside those flowers and be ready to pollinate first thing in the morning, way before you get up. Okay, so I want to go back to sulfur flowers. So this, again, was a sulfur flower. And these plants are called sulfur vegetables because they are basically self-pollinating. They're pollinated from regular, perfect flowers. So beans, peas, lettuces, tomatoes, peppers, and eggplant. These are really good species to start your seed saving with because you can pretty much grow them without having to worry about cross-pollination and know that you'll get good quality variety of your tomatoes that you like or your peppers or your beans. Now, and the really cool thing about this is that, we live in a climate that can get hot midsummer and we watch our lettuce bolt and we can feel sad about that, but now we can say, I'm making seed. So we can go from bolting to seed production pretty quickly. Okay, now you'll notice on the right-hand side I have a comment there about the Latin names. I've included the Latin names and I'm going to tell you why they're helpful to pay attention to. Your seed packet should have the Latin name on it, and if it doesn't, then don't buy from that company again, it's not helpful. The way Latin names work is there's the genus, which is the first name and it's capitalized, and then there's the species, which is the second name and that's small letter. And I'll explain why this is important in a minute. Okay, so now we're going to go to examples of crossers like corn and squash. These are some examples of crossers. Corn, as I said, crosses pretty easily. Cucumbers cross pretty easily. All the muskmelons, all the melons, all the squashes, these are all crossers. And if you think about it, you know how we always see those cornucopias of crazy looking squashes of all different shapes and sizes and colors? That's because they're just cross-pollinated like crazy. They're very promiscuous. That's how you can get so many cool looking, weird, but delicious tasting squash. So that's another thing. When you're saving seed, there's a level at which what do I want to say here? So I have a seed company and I have to be able to say that when you're buying this type of squash, a butternut squash, I'm going to be selling you a butternut squash seed. But in my home garden, I am nowhere near as strict because I'm just eating it for me. And if I mix a little bit of my butternut with my buttercup, I don't care, as long as it tastes good and it looks cool, I'm okay with it. So, we don't have to be so strict and rigid, and I just really think that's important to pay attention to. But, so when we talk about crossing, what are going to cross are the same species. So notice this. Let me get to the right place here. So let's look at our squashes. One, because I can reach them. So we've got different kinds of squashes. We've got the buttercups, the hubbards, and the marrows, and they're all the same genus, Cucurbita, but they're a species maxima. Then we have another type of squash, which is like butternuts, let's say down here. But they're Cucurbita, but they're a different species than horchata. So if the species is different, they're not going to cross-pollinate. So that's important if I'm trying to save seed. So that's why the Latin name is really helpful, right? They're not all the same. And in fact, there is a cucumber, Armenian cucumber under melon, because it's actually a type of melon, but we eat it like a cucumber. So anyway, so it's worth to pay attention to that. And watermelons, by the way, are a whole different genus. They're a whole different thing. So you could grow your muskmelons and your watermelon nearby and not worry about cross-pollination. Okay, make sense? Mm-hmm. All right, so then I'd just like to take this one over because I love this example. So Brassica oleracea. This is one species of plant. And it produces all of the things that we call brassicas. Our kale, our kohlrabi, our broccoli, our Brussels sprouts, our cabbages, our cauliflowers. How is that possible? I'm using my arms as stems or for leaves, and I don't know, the leaves just started to make these little rosettes rather than the leaves that we think of. And somebody thought that was great, and so we selected for that. We saved that particular seed, and they all make those little balls. A different type of that plant made the cauliflower, which is an odd version of the flowering head, and broccoli is a different odd version of the flowering head. You'll notice that the flower, right, those anthers are sticking way up. That thing crosses like crazy, right? The wind just blows and off goes that pollen. So the reason I bring that up is that if you're saving for seed of a brassica, you really only want to save one species at a time, right? If I want to save my broccoli seed, I'm not saving seed from any other any other brassica. Now, does that mean I can't grow all those other brassicas? No. I certainly can grow them all. I can even grow them right next to each other because I eat them before they go to seed. Right? We eat all of the brassicas we eat before they go to seed.
But I want to ask how far apart, if we're going to save the seed of the kale, how far do we need to be away from the whole mustard family?
Well, not the whole mustard family, because there'll be different species. So like your radish is a different species of brassica, but I'm just talking about the Brassica oleracea, so that's a good point.
Okay.
So I think I bring this up for this point, because this is also something where people can get kind of confused. I can grow all of these together in my garden and enjoy them all and have a feast and save them and freeze them and do whatever I do. But if I want to save seed, I'm only going to let one of them go to seed. And if I let two of them go to seed, I'm going to get chaos. Does that make sense? Okay. All right. So last thing of the crossers, besides what we think of as our intermediate crossers are the biennials or the overwintering. So all of those that we've talked about so far will produce their seed in the same year that you plant the plant to eat the food. There's another series of plants and these are typically the root plants, where they actually don't produce their flowers and seeds till the second year. We don't even think of these because we typically eat the root vegetables before they ever go to seed. So that's our carrots, our beets, our radish, all of that. These you typically want to, there's a special process for saving them in the winter time. Some of them you can save here in the winter, keep them in the ground with a lot of mulch. Some of them you actually need to pull up and keep them in wet sand at about 50 degrees and then replant them in the spring. And the thing about these plants is for them, what they've done is they put all their energy into their root for the winter time, to make it through that first winter. So all their energy has gone into making that root that we now think is a delicious carrot. And then the following spring, they use that energy to make flowers and seed, because actually seed production is very expensive for a plant. Okay, so these just need a little more thought. So again, garden planting considerations, if you're just starting out and you're kind of worried, just start with the sulfurs, like easy peasy. Here's the thing, tomatoes, you can save those seeds when the fruit is ripe to eat, the seeds are mature. So literally just squeeze the seeds out from your tomato when you harvest it, and now you've got seeds that's ready to save. This is corn that's ready to be harvested. That's not very attractive for eating, right? This has been left on the plant until it dried, because we're saving seed. Same thing for peas and beans. And what else is on my plants? So peas and beans, you're going to leave those pods on their vines until they're ready to be, the seed is ripe. So the husk is going to be crispy and dry, which is way past the eating stage. So you got to think about, I got to save some of these, and you want to save some pods. If you've got 6 or 7 different plants, save some pods from each of those plants, because they're all got slightly different genetics. Don't save all just from one plant. Make sense? Okay, peppers, you want to wait till that fruit is mature. So even if you're growing a green bell pepper, we're actually eating those green bell peppers when they're immature. So you leave it on the plant until it turns its rightful color, which is red, and then you harvest it. Lettuces, same thing. You want to let the seed head dry on the plant. Now, crossers. So we want to grow those squashes together, right? But what do? So here's what you do. Believe it or not. Remember I told you that the land bees sleep in those flowers? So you will never get up earlier than the land bee. It will be already awake and pollinating your female flowers before they sleep in the flowers. You can do it. You'll notice here's a female flower, because I can see the bulb at the bottom. When I've seen the flower, and it's already going to be ready to be opening, but it's not open yet, I tape it closed. And I do the same thing with my male flower. And I decided, okay, I found my male flower. And then I take my male flower's anther, and I use it like a paintbrush. I open my female flower. I paint the pollen onto the female flower, and then I tape that flower back up again. And then I somehow remind myself, this is the squash I want to save for seed. So it's a flag, it's a sign, it's a don't touch, it's a siren, it's whatever.
So if you get an accidental cross-pollination, so I had last year these zucchinis that crossed with butternut, and they were awesome because they were like these giant butternuts, but you can't save that and grow those.
Well, you know, you can. You'll just get a gamish and just keep selecting for the one that you like and keep saving it. And over a couple generations, it's not going to be as complicated as a true hybrid. And just keep selecting for the variety that's closest to that awesome flavor. And you've now made a new species, and you can call it, or not a new species, a new variety, and you can call it whatever you like, and share the seeds with your friends and neighbors.
Okay, but do it over like generations.
Yeah.
To get that.
Just keep saving the seeds, yeah, and you'll get some kookiness, but it's not going to be as complicated as if you're going from a true hybrid, for sure. Okay, so when you've got crossers.
Is that like that athletic tape? Is that what you use?
Oh, no, I just use like the blue sticky tape.
Okay.
For masking tape. This we did saved some seed for two bear, and we just made an isolation cage for them because the carrots are insect pollinated, so this protected them. You can also plant at a distance that's farther than the pollen will travel, either by insects or wind, depending on the plant. You can also time plants differently, so some will flower earlier than later. These are mechanisms that people have evolved for managing that capacity for cross-pollination. Or only grow one variety of your Brassica oleracea that season. This has a description of each of the plants, what their name is, how they're pollinated, the isolation distance, and you'll notice corn is up to 1 mile. I mean, it's incredibly hardy. The number of plants in an ideal seed you want to be saving seed from, and some seed saving notes. And again, these are for people who really worry strongly about purity. For the backyard grower, we're a little less strict, which is why we have all this biodiversity that our ancestors gave us. It's fabulous. I think there's over 10,000 varieties of rice alone. It's incredible. So, and this is the advanced. Okay, so lots and lots and lots and lots and lots and lots of resources available online, YouTube, books. The Good Seed Company, Flathead Grows Community Seed Library, Center for Sustainability, and Entrepreneurship all have workshops, and at least the Whitefish School District Education, Community Education System, all have workshops that are free or nominal cost for learning more. So there are a ton of resources available for you. And then this is a plug for our community seed library. We have a community seed library in the Flathead Valley. This is a partnership with the Good Seed Company and Imagine If Libraries. It's dedicated to helping teach our community to save seed and build our seed supply. So I really invite you to participate. Think of saving seed for them. Think of coming to a seed packing party. Think of offering your resources at a workshop. You are the means by which we can build a resilient seed community. And come back to Free the Seeds, host a workshop, host a booth, share your knowledge with others first Saturday in March, as you know. And lastly, I wanted to do a plug for arrowmontana.org, arrowmt.org. It's an organization dedicated to sustainability. It is the foundational sustainability organization for our state from 45 years ago that promulgated the excitement, interest, and energy that produced the legislation and organizations in our community today related to renewable energy and sustainable ag. And they now are dedicating their efforts to helping empower communities build resilient food systems, because that's the next level. Any level of donation on a regular basis will make you a member, and you will be supporting yourselves and your future. And that's it. Be curious, take it lightly, and mistakes are welcome. Go plant. Thanks so much.